Hey there, folks. Apologies for the delay. Just getting things kind of set up here. Um, I've got Slack here on my phone, so I'm going to monitor the thread. Feel free to ask any Python questions, either from our material or it can be a Code Wars problem or somewhere from wherever you might have questions. Feel free to bring those in and just give me directions, a link to it, or a problem description, any code that you want me to troubleshoot, and we can go from there. Cool. Since I'm not seeing any questions yet, I'm going to go through the material. Looks like we left off on accumulators last time. I kind of thought we had finished. Yeah, evidently we did finish accumulators. So we finished accumulators. I think this page just isn't updated for some reason. So that's done. Okay. So it looks like we're going on to break continue pass here. Let's clear these out. Okay. So break, continue, and pass overview. Okay. So quick note on this. Break and continue have to do with loops. So these are keywords that are built into Python that have directly to do with for and while loops. So these bear on loops. Their application is inside of and in the context of looping. They help us control the loop. Break will just stop the loop totally. Continue sort of skips one iteration and just it stops that iteration and then wherever that continue line is run and then goes on to the next one. So you might have a special case that you check at the beginning of your loop and or wherever in the loop that tells you, okay, don't execute the rest of the code in the loop. Just continue on to the next iteration of the loop. So break stops the loop totally. Continue just moves on to the next iteration of the loop. In every programming curriculum that I've when I was going through programming curriculum as a learner and every programming curriculum that I've encountered as an educator now presents these three ideas together: break, continue, and pass. And a lot of other languages have these same three keywords that do the same thing, and so does Python. So I just want to make this. I just want to sort of point this out now so that there's no confusion. Again, break and continue bear on loops. Pass, for some reason, is always taught with break and continue. I'm not sure why. Pass has nothing to do with break and continue. Pass is a keyword. Pass can occur. You can use pass inside of a function. You can use it inside of a condition. You can use it at any point, anywhere in your code. You can throw a pass. What it is valid code that doesn't do anything. The reason it needs to exist is that certain times, in certain contexts, Python will expect something, some code to be present. And there are certain times when you just want to fulfill that presence of code, but not do anything. Mostly, it's useful as a placeholder for saying, I'm writing this now, but I'm going to come back to it later. So I'm just, you could write, you'll see this in our in the learn material where we'll write a function head, like def such and such function takes these arguments, and then we want you to fill out the body of the function. We'll give you a problem statement. So given this function name and these parameters, we'll write it out for you. Complete the rest of the function, and you're supposed to figure out how to solve the problem. and what to return and all that. And we'll throw a pass keyword in under the function as the body of the function. And that's a good practice, because if we don't throw that pass in there, if we tried to run the code, we would get an error. And I'll demonstrate this. So that's most of pass's role, is when you, for whatever reason, you have Python is expecting a body of code that you don't want to supply at the moment. You want to come back to it later and do something. There is only one scenario where I know of it being sort of a permanent feature, and that's in error handling, when you want to catch some error that happens and then just ignore that particular error. And that can be dangerous in different ways. You don't necessarily want to ignore errors. It's usually better to write your code in a way that where you're not going to get the error in the first place. But sometimes it's really easy to say, oh, well, I'm going to do this process. I might get this error, and if that happens, I have something else that I want to do, so I'll ignore the error. So you'll say pass in that place where you would otherwise ignore that error. So okay, but we're not going to get into error handling. That's a topic for a very different day. So let's talk about pass real quick. I was talking about functions, and most of the use case for pass is as a placeholder. So let's say def function to complete takes in A and B. I don't know why I typed a 1 there. So if I run this, code, I'm going to see where the output down here in my terminal. Oops. Okay, so I get this funny error, right? It says syntax error, unexpected EOF. EOF is an acronym for end of file. So unexpected end of file while parsing. It's kind of funny, but a file ends when it encounters a file ending character or end of file character, usually just called an EOF. So a file ending is actually a character in the same way that like an F or a white space or a colon is a character in UTF-8 and ASCII. So it says unexpected end of file while parsing, and it points here. It's kind of pointing right here. And that's because Python sees the end of the file, but it was expecting, it doesn't tell you what it expects. It tells you that it's a syntax error, but it doesn't tell you that it's expecting a body to the function. So this is kind of a funny one, because it's uncharacteristic of, I would say, most Python errors. It's not as helpful as a lot of Python errors in terms of it doesn't tell you exactly what it wants you to do to fix it. So in order to make this work, we can throw in a pass here. And notice my syntax highlighting kind of fixes itself. This is not how my syntax highlighting is supposed to look for valid code. So I have to supply a body to complete this. And my syntax highlighting sort of rectifies itself, and when we have the pass in here like this. And notice when I complete typing pass, it turns purple like def, because that tells you it's a special reserved keyword in Python. So we can say pass there, and I'm just going to print something. And then when we see this hello, we know that the Python interpreter made it to this line. We can confirm that this file is running this way. So this is a good example of using pass, like you're going to write the function head, and you're going to come back to it later. And this happens a lot where you're like, oh, I have an idea for how to solve this problem. Well, I might need to write 2 or 3 functions for this. Okay, so I'm going to need to write this function, and it should take in these inputs, and this function, it should take in these inputs. So if you have 2 or 3 function heads that you need to come back to later, you can't test any of them out until you have valid syntax in the whole file. So You might want to throw in a pass as a placeholder, just saying, I'll come back to that later. Okay. So that is the use case for pass. Pass is a placeholder. I know I've said this over and over and over. The reason I'm harping on it is because I remember when I learned these, I was with a group of students actually at Galvanize in our cohort, and this was so confusing to so many of us. We were like, okay, break and continue do this and that to loops. So what does pass do to loops? And it was just it's kind of a comedy of errors. Like there's some reason this particular thing, we just kept talking past each other, and nobody said, hey, you know, like we presented these 3 keywords together. 2 of them are kind of a piece, and one of them is not, you know. But it's kind of funny to me because I don't know why this is. It isn't just at Galvanize. It's like every programming pedagogy, you know, tutorial or whatever that covers this groups them together, and I'm like, I don't know why. So, c'est la vie. Okay, cool. So we'll come back to that. Let's actually jump into the lessons. Let's just read through this. So by the end of this unit, we want you to know how to use the break, continue, and pass keywords in, this says pass in loops or functions. So I would say we want you to know how to use break and continue in loops, and we want you to be able to use pass as a placeholder for functions, loops, conditions, or other parts of Python code that require a body. So unit overview, break and continue are commonly used within loops to either bypass some code or exit the loop itself. There are a number of reasons you may want to do this, either to optimize your code or prevent further or unnecessary calculation. In general, pass can be seen as a placeholder for code in order to allow your function or loop to run. We'll skip that. Okay. Oops. Yeah, I guess we'll just get into the examples in the next one. So we're going to talk about breaking. If the page loads, we will talk about breaking. Cool. Breaking loops with the break keyword. By the end of this lesson, we want you to be able to break out of a for loop and break out of a while loop. Good news is it kind of makes it sound like, oh, maybe there's something different that you need to know. Not really. Let's just do an example of breaking out of each one just to see how similar they are. So let's say for I in range 10, let's say print I and break. Okay. Ask yourself, you know, given that I said break just stops a loop, what's going to happen here? You know, you might look at this, you might come to several different conclusions. There is one thing that it does, right? You may come to the wrong conclusion, but that's okay. Just notice you make an assumption if you do, and if you don't make an assumption or you don't know what's going to happen, then note that as well. Okay, so we get 0 printed out, right? So for I in range 10, range is going to start from 0 and go up to the number that I pass it, if I pass it one argument like this. So it's going to start at 0 and go up to but not include 10. That'll give me 10 iterations, 0 through 9. So this prints out I. All it does is print out I, and then breaks. So we print out 0, and then we stop looping, right? So, you know, not particularly useful since it's only going to limit this for loop to only one iteration. It's going to limit that for loop to only one iteration. So maybe something more useful, and what you tend to see is you'll see break hidden under a condition a lot of times. So we probably don't want to just break like right in the loop like this. We probably will want to break under a certain condition. So let's say if I squared equals, oops, I have to actually finish typing. Da, da, da. Okay, so if I square equals 16, then we'll break. That's kind of a silly example. Why don't I just do if I, it's kind of makes it more complicated. If I greater than 7, then we'll break. So think about what this might do. Just give yourself a second to think about. We're going to have a for I in range 10, 0 through 9, and just print I. So what numbers are going to print? You might ask yourself that. It's running, so it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So it gets to 7. It says if 7 is greater than 7, which is false, 7 is equal to 7, so it doesn't break. And then it gets to 8, and if 8 is greater than 7, which is true, then it breaks, right? So if I wanted to break earlier, I could do something like that, right? Now this is also, again, not that useful because I could just, limit my range somewhere else, but occasionally, let's say, I say like, let's say I have a function like def squares list. Oops. So this will take in a list and will return a list of all the numbers in the input list squared. So let's call this in list. And then let's just call this, so let's give it something valid. Let's say print, we'll give it a valid case, a list of 2, 3, and 4. And let's give it an invalid case. Let's say what we want it to do. What if we get a string in there at some point, like hello. So we'll say list. We'll start our accumulator. This will be our output list. I'm just going to call this out list. So for I, oops, I'm all over the place here. For num in list, if type num is not equal, or we'll just say if type num not in either, if it's not either an int or a float. So if it's not in int or float, then we can't square it. So let's just break. Let's just quit the function. We're going to go up until we encounter something that's not a number, and then we're going to stop there. So let's give this something a little more to do. I don't know. Looks good. Else, we'll say out list dot append num squared, and we'll return out list. Good. Excellent. Oh, I said in, I meant int there. A little typo. Okay, cool. So if you look, I have my first call, which gives me 4, 9, and 16. That's because 2 squared is 4, 3 squared is 9, 4 squared is 16. If I square, or if I run it with this list that has a string in it, right? I'm going to square 2, 3, 4, and 5. Then I get to this this string here. It checks if the type of num, and that's really that element. So this should really be, let's call this element because we're not really sure, lm. We're not really sure what type it is, right? It could be of various types. So if the type of the element is not in the list of these two type specifiers, this line just checks if it's not an int or a float. This is how I like to do it. So if it's not an int or a float, then we're just going to break. We're just going to stop and return. So that'll break your loop. That's one way to break a loop. Yeah. I said I'd show break for while loops as well. So why don't I do that? One of my favorite ways of writing while loops uses break kind of every time. I know a lot of people struggle with while loops. There's something, while loops they're a loop like a for loop in that they repeat a process, but they also take a condition like an if, right? So they're related to both, sort of, although I think categorically they fit more in the role of a for loop than they do an if statement. So an if checks its condition. If its condition is true, it runs the body of the if statement. If not, then it just goes on. Maybe there's an elif after it, in which case it checks that condition. If that's true, it runs that body. If not, it moves on. Maybe there's an else, which means it's just going to run whatever's in that else, only if all of the prior conditions were false. That's what else means. Else is like saying if all prior conditions, in the conditional chain that the else is at the ending of, if all of the prior conditions are false, then it's going to run that else. So that's regular control flow with if, elif, and else. Checks a condition, executes the body if it's true, and it doesn't if it's false. Right, pretty easy. So with a while loop, it checks the condition, and if the condition is true, it runs the loop, and then it runs the body of the loop. Then when the body of the loop ends, it goes back up to the top and checks the condition again. That's all it is. So it's a lot like an if, but it just keeps checking the condition and keeps running the body of the loop until this condition is false, right? So what that means is in your condition of your while loop, it has to be comprised of at least one thing that changes, right? One way to do it is you have something that something whose value changes, which would be, let's call it a variable, because its value changes, its value varies, right? And you're checking that variable against a constant, something that, at least in the context of the loop, does not change, something that's consistent, right? So an example of that for a while loop would be, we could increment I. We could say I equals 0, and we'll say while I less than 10, right? So 10 is not going to change. 10 is 10. It's just the number 10, obviously. And then I is something that we have agency to control. So we could say I is, I plus equals 1. Right, so this is a common simple example of a for loop. And let's just let's print I here. I always like to get this incrementation of my controller in as soon as I write the head of the while loop, because without it, if I wasn't doing this, then we'd just get into an infinite loop. We could run this and we'll just see. It's going to print zeros for forever. I'm trying to select this and it's just shooting it up, and I can feel my CPU heating up, so let's stop that. All right, cool. I'm trying to think of a good while loop problem, a nice bite-sized while loop problem. The problem is a lot of the while loop problems are sort of getting into, other. They're starting to get complicated, even the simple ones. A little complicated, at least. But, yeah, let's just stick with the simple example for now. So, here's the thing. I notice a lot of people have, like, a conceptually difficult time with while loops. And I think part of this is you go, okay, I see it's a conditional controlled loop. So I understand if, and I understand for loops. So it's a loop like a for loop, kind of, fills the same role, but it's controlled by a condition, just like an if is. The only difference is that it's unlike an if, it comes back and keeps checking the condition. So what that implies is that you have to modify something that is being checked in the condition. It also means that you usually will loop until you find something that you're looking for. And it's usually easier to think, what's the scenario that tells me I have met the condition that I'm looking for, rather than thinking about what's the scenario that tells me I have not yet met the condition that I'm looking for. Okay, so let me rephrase that. So let's say our condition that we want to increment I until I is until I is equal to 10, right? This is our success case, right? This means that we found what we need to find, right? Or maybe, what's another? Actually, I'm thinking maybe if like I is the square root of n. Let's do that. So like, let's say I is the square root. I equals n to the 0.5. And that means I is the square root of n, right? And let's say n is 16, right? So this is an easy one. We can do this in our head. So we want to get I to the point where it's 4, right? Because 4 is the square root of 16. And this is our success case, right? And this is easy to think about because I know that I'm thinking, okay, I've got to get whatever the square root of n is, right? And let's say this is some variable that I don't know. This could be maybe something that doesn't really have a square root, in which case it would be I guess actually we could just do n squared. N squared, right? Let's do that. Then we'll definitely encounter it, at least. Okay, so let's say n is 4. We'll just flip it around. So 4 squared is 16. And we want to get n or I up to whatever n squared is. So what I can do is I can say, while I not equal n squared, right? But here's the funny thing. What I'm thinking about here is my failure case in this while loop. I'm thinking about while I is not what I want it to be, keep looping, right? It's kind of much easier to think about stop looping once I is what I want it to be. So what you can do is we'll do I plus equals 1 here. And then I'm going to have my exit condition here. And I'm going to say if I equals n squared, break. Okay. Oh, this is a lesson on break, and I've spent all that time talking about while loops. But I think it's worth it because while loops seem to be something that people struggle with, which I totally get. And this is like my favorite use of break. So what I usually do when I write a while loop, I don't even worry about the exit condition here. I just say while true, right? Remember, a condition is any expression that evaluates to either true or false. Well, true is an expression that evaluates to true, so it counts, right? It seems weird. I will say, I think there might be some controversy around writing while loops this way. I won't guarantee that every other programmer that you encounter would suggest this as a good idea. I suspect that some people would sort of inherently think it's a bad practice, but I kind of stand by it. I like this way of doing things. I think people would look at it and say, well, you know, if you do a while true, you're just locking the while loop on forever, right? Like this is just an infinite loop. And to me, when I'm writing a while loop, like I assume that every aspect about it is kind of dangerous, and there are going to be elements of using that while loop that are sort of risking getting into an infinite loop. There are certain scenarios where it's like really hard to isolate every scenario that might lead to an infinite loop. It can be sometimes hard to think about. So my rationale for this is, since problems that require while loops can often be sort of confusing to think about in the first place, just make it easier on yourself. Rather than thinking about what's the case that I don't have what I'm looking for, and writing your condition in on line 16 here, it's much easier usually to think about what's the case that I do have my condition for, that I do have what I'm looking for, that I can just stop looping, right? So it's kind of ironic, but I find this easier to manage mentally, thinking about that we have a success and we can stop looping, rather than we have a failure and we have to keep continuing looping, right? So that's why I like to use break here. Also, when you see while true, it sort of just reminds you that, yeah, this is a little bit dangerous and it requires the attention of making sure that your exit condition is in place. So this is the way I like to do things, but just full disclosure, disclaimer. If you do things this way, you may frighten people. You may somebody might say, well, that's not best practice, and I don't think that's actually canonical. I don't think there's anything in Python that says it's not best practice, but it's also a weird scenario. Okay, but anyway, so that's my opinion, and I'm sticking to it. Cool. So you can see, hopefully, I mean, these are different problems. I have this square list thing here, and I have this other problem here. But using break in the context of a loop, all we need to do is just write the break keyword, and that just, once Python runs this line, and in either case we have this break hidden under a condition, once Python encounters this line and runs the break, it just stops all looping. It's just loop over. We can prove that like this too. Loop over. If it runs, okay, cool. let's break. So let's look through this lesson, see what it says. Cutting an iteration short. 2 primary reasons you should use break, including exiting a for or while loop, when further computation is no longer necessary, and avoiding or exiting an infinite loop when using while loops. This is sort of another scenario that I kind of like laying out a while loop like this for, because let's say I don't want to necessarily, I might not just be trying to prevent infinite loops, right? You could have a virtually infinite loop if something is going to run like 10 trillion times and not complete for hours when, if that's the case, maybe you want to just say, no, I don't even want to do this, try up to 100,000 iterations, and if that doesn't do it, then just stop and we'll do something else, right? So let's say we'll stick with the same problem, and I'll just have a limit. We'll say limit equals, actually I don't need a limit, I'll just use I for this, right? So let's say n equals 100,000. We'll say n equals 100,000, and we'll break. In this case, this is our success case, right? We'll say success case. Right, so this means we found what we're looking for, so we don't need to do any more loops. I don't need to make this 100,000, that's way too many. And I'm waffling. Do need a limit. Limit will be, let's just say, also 10,000. So our limit is going to tell us, like, okay, maybe we didn't find our success case yet, but we'll say if I is greater than or equal to limit, which is also 10,000, then we can also break, right? So I can have multiples of these conditions. In this particular case, I could do this actually with an or here and just limit it to one condition like this. I could squeeze this all in to here, but maybe maybe I want to do, if I reach this limit, maybe I want to print no value found for I, no matching found for I, terminating loop, right? So let's just run that. It's probably going to take a second. I probably shouldn't have used super high numbers. Oh, okay, it got it. Okay, so no matching value found for I, terminating loop, right? So there might be, if I encounter this specific scenario, there might be additional lines of code that I want to execute in addition to the break, right? I might want to just say, I might also want to just reset I to 0 and just say, like, okay, I equals 0, and then we'll break. Even though I equals 0 and it's no longer less than the limit, it's not going to come back and check the while true, right? It's just going to break, and then the loop is over, right? So this gives me, thinking about your while loops as, okay, when do I find, what's the condition that tells me what I want, and then under that condition, just break. Also gives you the opportunity to break under multiple conditions, right? There may be multiple things that tell you that you need to stop looping. Perhaps it's a success case, and perhaps it's like a failure, like a total failure, like, okay, we're not going to do this anymore case. Right, a failure case. So that's another great use for break. Okay, cool. Back to this. Avoiding or exiting infinite loops with while. Yeah. So we showed break in a for loop. Important to note here, I know I said this before, so at the risk of repeating myself, I think it's safe to say that break inside of a loop is always going to be hidden under a condition somehow, because if it's not, then it's just gonna it's gonna break the loop immediately, which you probably don't want to do, because then there's no point in having a loop. So we'll say if num equals 50, then we'll break. And this says for num in range 100. This is very similar to the first example that I gave. So we see some condition, and if that condition is met, then we'll break. Slightly more complex example. Ooh, nice. Okay. So this is an isPrime function, which I will write. There are other ways of doing the isPrime function. I'm going to cut this. I'll pop it in test.py. There's sort of a different way of doing the isPrime function that I really prefer, but this is a good example of break as well. Okay, so we've got isPrime is going to take in a integer, and it'll tell us if it's prime or not. I'm going to call this in a for loop. We're going to say for I in range. Let's just say 1 through, well, we don't need 1. We know 1 is not prime. Actually, let's do 1. Yeah. 1 through 15. Plus 1. Okay. Then we'll print I and isPrime of I. And this will either tell us true or false whether the number is prime. So these are small numbers. It's easy. It's going to be easy to just look at them and tell whether they're prime or not. If you don't know, because I've had some people say they don't know what a prime number is. Prime number is just, it's a number that can't be evenly divided. So it's going to be an integer that can't be evenly divided by any other number other than, of course, 1 and itself, because every number can be divided by itself, or every number can be divided by itself. So, like n over, or every number can be divided by 1, right? So n over 1 is n, and n over n is 1. So other than that, prime number has no factors, is what we say. The factor is a number that divides evenly into the prime number. So let's say def isPrime takes in n, and we'll say if n is less than or equal to 2, we're just going to return false. Or they're doing the variable solution. Yeah, they're okay. Prime equals true. Oh, wait. Crazy. I'm going to do this in the way that I know how to do it. Return false. Okay. So let's just say, so if n is less than 2, we'll return false. Otherwise, we'll just say for I in range 2, to n, and we don't want it to be inclusive. We don't want to divide by n, otherwise it'll be divisible. Then we'll say if n over I has a remainder of 0, right? So we need the remainder. We'll do modulo. So if n mod I equals 0, if the remainder of n over I equals 0, then we'll just break. And, oh, I have to do the variable solution. Ugh, the silly variable solution. Prime equals true. Prime equals false. This is going to be prime equals false as well. Okay, so we need to make prime false and then break. And then we'll say return prime. Okay, I think I did it right. So let's see. This is not usually the way I do this, so we'll see. I'm not actually looking at it. It looks like I can see this on OBS, but it's actually covered by the other window for me, so I'm not just copying it. Cool. So 1 is false, 2 is true, 3 is true. Okay, 4 is false, 5 is a prime, 6 is not a prime, 7 is not a prime. Okay, good. It looks like it's working. All right, so here's a way we can break. And this prevents the loop from, checking any further cases. We found n mod I equals 0 at some point, so we already know it's not a prime number. We can just say, okay, prime is false and just break. What I prefer to do is usually just return false. And this is interesting because return often is used to break a loop, because return is not intended necessarily as a break for a loop, but return tells the function to have an output, and once the function gives an output, then it stops any further code execution, even including right in the middle of a loop. So return in this case is a de facto break. And a lot of scenarios, a lot of times, like, you might have a while loop, you're looping through something, and you're like, okay, well, if I encounter this condition, I'll just break, and then I have what I need, so I'll return it. You can just skip the break and just return the thing immediately in the loop or under the condition that you would break under. Save yourself a step, but either way. Does it really matter? I don't know. I mean, just sort of a preference thing, I think, at this point, sort of clean code aesthetic thing, really. Okay, cool. Yeah, I think we covered breaking out of a while loop well enough, actually. I'm going to just move us forward. Oops. I don't know why it's asking me to save. Cool. Complete the contains even function, which checks if a given list of integers contains any even numbers. Do not iterate over the entire list if possible. Gosh, excuse me. Okay, so we've got this list here. So let's have, and it's just going to return, I think, true or false. Yeah, if it has any even numbers. So this is kind of actually pretty similar logic to the isPrime function. So let's have a couple of cases. Let's say contains even, and we'll have a list that contains no even numbers. And then we'll also have a list that contains even numbers. Okay. So this first one should be false, and the second one should be true. Good. So what I want to do is just say for I, or we'll say for num in list. My input is called list up here. I'm calling on my input. So for num in list, if num, oh yeah, evens. I'm like, wait, what do I check it against? I'm still thinking of if isPrime. So if num mod 2 equals 0, then we know it contains evens. So we'll break. I've got to set some sort of variable. So let's say rest. I'll just call it rest for result. I'm going to start it at false. I think I need to start it at false. False. And then we'll say res equals true. We will break, and then we'll return res. False and true. Okay, cool. As an alternative, oops. As an alternative, I think we can just do yeah, and we don't need the break. So again, I'm using return as a de facto break. I'm like, okay, I found what I want. I know in this case, that means I can just return it straight from the function, right? So num mod 2 equals 2, just return true. So these are pretty much equivalent. I prefer the latter, although the former is an example of using break, which is kind of the point of this exercise. So I'll copy this in. Just that. Cool. Yeah, and they wanted the Boolean flag solution right there. Good. All right. Sum too large, list and threshold. So if the sum of a list of numbers is greater than a given threshold, so it checks if that's the case. Okay. So I'm gonna hack this one because I think I can do it, and I just want to. So we'll return list. Let's do, oops, some list greater than thresh. I'm just curious. Huh. Okay. So that works. I can just sum the list and see if it's greater than the threshold, right? But presumably they want us to use break because that's what the lesson is about. Okay. So we'll say, I'm just going to say res. Again, we'll start it at 0. For I in list, I'm going to call this lm, or no, I'm going to call it num. For num in list, res plus equals num if res greater than thresh, break. You know, res is not a good name because this is not the result of the function. Let's call this ACC for accumulator. And we'll say res equals, our result is going to be, what are we going to do? False? I think that's what we want to do. Then we'll break if ACC is greater than thresh. We'll say res equals true. And then after that, all that's said and done, we will return res. This is a good example. If you went through the Boolean accumulators section, if you found that, because I know a number of people have said that they found that confusing. This is a good example of a Boolean accumulator essentially. We start, or a Boolean flag. We don't really call them Boolean accumulators because it only has 2 states, and it's hard to think about accumulation as applying. But this is a flag pattern, which is the analogy of an accumulator pattern in a Boolean. We start value at one thing, and we check a condition, change it accordingly. In this case, we will break under that condition as well, return it. This has multiple accumulators. Oh, I didn't run a test, but you know what? Against my own advice, my own constant advice to you all, I'm going to submit it without testing it. I'm doing it. Okay, that's correct. Cool, and let's see their solution. So too big equals false. That's what I called res. ACC, same name, same role. It looks like starts at 0. For num in list, that's also the same. ACC plus equals num. It's all very, very much the same. Then if ACC is greater than thresh, too big equals true. We break and return whatever the value of too big is. Looks like I solved this one previously. Let's just cut this and reset the input. Let's do this. Just going to do this just to save it so I can have that solution. But I haven't seen it. I didn't really read it, so. So this is going to find all the prime numbers in nums. Interesting. Okay. So it looks like we have a list of numbers, and we're going to return what? A list of all the prime. Okay, so if it's a prime number, then we're going to return it. I think I just want to write an isPrime function. So let's just do def isPrime, takes in n, and we'll say if n less than 2, return false. For I in range 1 to n, if n mod I equals 0, return false. Return true. Or in range 1 to 15. I'm just going to check this really quick. Print I is prime. All right. Just find that really quick. Oh, that's broken. It's always false. So what did I do wrong? So if in is less than 2, we're going to return false. For I in range, 1. That's what I did. Because we're going to always be starting with 1 and everything's divisible by 1. Okay, cool. There we go. That's better. We want to start at 2. So 1 is not prime, 2 is prime, 3 is prime, 4 is not prime, 5 is prime, 6 is not, 7 is prime, 8, 9, 10 are not prime, 11 is prime, 12 is not, 13 is, 14 is not. Good. Okay, so is prime function is working. Find primes. So what we want to do now, we'll say, I know I want to do for num and nums. Let's actually build a test for this. See, I'm using pass. I'm just using this as a placeholder for my for loop because I'm going to come back to that in a second. So let's do print, find primes, and we need to give it a list. So I'm going to just give it, we'll give it 2, 4, 11, 15, 27, 18, 19. Okay. So this should give me all the primes. So for num and nums, if num is prime, if, is prime, num list.append num. Let's make list exist, list equals a list, and let's return it and just run. Okay. Two, 11, and 19. Good. I was supposed to use break. Okay. Was I supposed to use break? I'm going to submit this. Perhaps maybe I misunderstood the problem statement and this will fail. I think this will work though. It fails. Okay. Oh, right, because I built this other function. So I'll include my helper function, which we can do and learn. Okay. Let's do that. Okay, so that does work. So let's see what their solution is. Quite a bit more. So this is their isPrime function. Of course, mostly this is just extra comments and stuff, just kind of explaining the code. They're doing this with the break example, which is a different way of doing it with the break and the variable style. I'm using the return as a break. And then for this, if is prime num, primes append. Yeah, okay. Yeah, so this is not using break anyways. I guess they wanted us to use break in the isPrime function. So, and I'm curious, evidently it had solved this before in a different way in a single function. So let's just look at this really quick. See what this was. Here's, I guess, an alternate solution. We have find primes of list 1. This doesn't look like code that I wrote. I must have helped somebody with this. So we have list 1 as our input, list 2 is our accumulator for in our input list, which is list 1. If n equals 1, continue, right. So this is sort of the isPrime logic. Let's say if in mod 2 equals 0, continue if inmod2 equals 1, list to append n. Well, this actually shouldn't work. This is definitely not code that I wrote. I don't know what's going on there. So that is actually not a valid solution for this, although weirdly learn appears to accept it, which is weird, but that's actually not checking if it's prime. So, all right. We should go in and update the tests in this. Cool. All right, skipping loops. This is going to get into using continue. So by the end of this lesson, you'll be able to use continue. So here you'll use continue to separate squares from non-squares. You could easily write another way without using continue, but this demonstrates continuous functionality. Okay. This is interesting code. We have a non-squares list. We define a function. Is square, which presumably is going to give us true or false. Yes, looks like it. So for I in range 2 to num, if I squared equals num, return true. If I squared is greater than num, just break. It's just going to break. Because we know we're, like if we're checking 5 and num is 16 and I is 5 and we do, sorry, because we would have gotten true for 4. So if num is 17 and I is 5, 17 is not a square number. If I is 5, 5 squared is greater than our number, right? 5 squared is 25, so it's greater than 17. So this says if I squared, if 5 squared is greater than 17, we would break. So that would be if 25 is greater than 17, then just break, because we know we're not going to find a square, and then false. Now we could do return false here instead of break, but you could also use break there. And then we have for num in range 2 to 101. It's really 2 to 100. If is square num equals true, continue. If not squared, append num to not squared. Let's look at the output of this. Let's just run this. And we're going to get a list of all the non-squared numbers. Let me cut this and run that and paste this right there. Cool. Two, 3. We skipped 4 because 4 is 2 squared. 5, 6, 7, 8. We skipped 9 because 9 is 3 squared, etc. Right? So continue it's kind of like break, but only for one iteration. You might think of, and I think perhaps continue would have been better named as skip, like skip iteration. You can think about it as skip iteration. That's what it does. It just skips this trip through the loop. So if the number is a square, we actually don't need this part. So if is square num, if the number is a square, if that's true, then we're just going to continue and we're going to avoid this append, right? Cool. Are we on? Wow, okay. We're on the challenges already. Complete the sum only evens. Okay, so we have a list. Let's call this sum of evens equals 0 for num in list if num mod 2 equals 0. So if num mod 2 equals 0, that means num is even. Then we'll say sum of evens. This is, wait, I'm supposed to use continue. Wait, what am I supposed to do? If num mod 2 not equals 0, okay. Then we'll continue. If we don't continue, then we'll end up running this line. And then return sum of evens. Bingo. Okay, cool. Sum only evens. We have our ACC. For num in list, if num mod 2 equals 1, I just said not equals 0, whatever, same diff. Continue. Otherwise, ACC plus equals num, and then return ACC. Okay, picky prod function, right? Complete the picky prod function, which takes a list of numbers and multiplies those which are not multiples of 3 or 7. So if the number's not a multiple of 3 or 7, then we successfully multiply it into the product. Try to remember that the point of this challenge is to use the continue keyword. Okay, cool. I will try to do that. So let's say I'll do ACC, or wait, what do I want to do? Prod. I'll do prod equals 1. We got to start a rolling product. We have to start at 1, because if we started at 0, then it's going to be 0 forever. Because we're going to do times equals, remember? So if I say, 0, prod at 0 times equals anything else, and it's 0 times that thing, it's probably going to be 0 again. We're going to keep having the same problem. So for num in list, if so I know I have to do mod 3 and mod 7. So is it yeah, just num, if num mod mod 3 and num mod 7, okay. Or we'll say or num mod 7. And what do I need to check these against? Let's see here. So the product of lists that are not multiples of 3 or 7. Okay, I'm doing some like tongue twistery stuff. So I know I'm going to say prod times equals num here, and then I'm going to return prod. So I need to, I'm just trying to get all the scaffolding in order. I know that the consequent of this condition is going to be continue. So if num mod 3 equals 0, then I want to continue. Okay, cool. If num mod 7 equals 0, then I also want to continue. Continue thus prevents prod times equals num, which means I don't take the product of those numbers. Oops. Let's see if that's going to go. Cool. Okay, that works. So here we have prod. This is probably going to be exactly the same code. I think it is verbatim, line for line, character for character, the same. Except for the comments. Prod equals 1 for num and list. If num mod 3 equals 0 or num mod 7 equals 0, then we continue. Otherwise, we're just going to prod times equals num. Great. So which numbers will be printed when running the below code block? Well, here's a way of answering that. Cool. So 0, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 13. Okay, let's see. 6, 7, 13. Do we have 6, 7, 13? So one of those two. 6, 7, 13, 14, 15, 16, 17, 18, 19. 14, 15, 16, 17, 18, 19. Okay, good. It'll be that one. Cool. Well, let's just check this. If num, so for I in range 20, if num, or if I, excuse me, I don't know what's wrong with my eyes today. If I squared is greater than 64 and I squared is less than 144, continue. Which prevents the numbers whose squares fall within that range between 64 and 144. Then, so we'll continue and exclude those numbers. Otherwise, we'll just append I every time and print the list at the end. Cool. Good. Passing over conditions. Okay, remember, break and continue have to do with loops. Pass doesn't necessarily have to do with loops. It's a placeholder. Use pass as a placeholder in an unfinished function for now. So for now, consider pass as a way to avoid committing an operation when writing a function stub, such as this, or a placeholder for a function that you will write in the future. Pass is a function, or excuse me, pass is a common way to avoid your code erroring when it runs. In addition, pass can be used within a for loop or if statement in order to do nothing. That's true. It literally just does nothing. There are times when that can be useful. So here's some function names, and we have pass because they're not done yet. Here we have a for loop with pass. Pass does nothing, so this is valid code. If the pass wasn't in there, it would be invalid code, even though there's this comment in here, right? So there has to be valid Python code that Python recognizes as valid. Pass just says, hey, I'm code. Don't throw an error. Same thing here. In your own words, to describe when you use break, continue, and pass. Break for, let's say, while loops. I do this. Break. Whoops. While loops. will be when you need more granular control over stopping the loop. Break allows for breaking for I'll say stopping any further loopage. I'll say looping. Stopping any further looping under multiple conditions. While, or that's while, I'll say for. For loops, really kind of same as above, same as while loops. You may find a condition that makes any further looping irrelevant. How do you spell irrelevant? Okay, use spell check. Dot. Cool. Continue. I'll just say with loops for and while. When you want to skip a specific iteration of the loop. So you meet some condition and you realize, okay, we don't need to execute the rest of this loop iteration. We can just skip to the next. Path is a placeholder for any I'll say for anything in Python that requires a body of code, i.e. a function, condition, or a loop, to name a few. There are others like classes, and there's error handling stuff, try except, things like that, but cool. All right, while loops overview. We already kind of dove into this. We're getting into a new section. We've got 2 minutes left before our usual stop time, so I think this is a good place to wrap up. I didn't see any questions today. Feel like we got through, feel good about the way I got through break, pass, and continue, although I didn't see any questions, which is a little bit of a bummer. I do like the, I mean, if you just enjoy watching, you're not obliged to interact if you don't have any questions or anything. Sometimes it's nice to just watch along, which is fine. But yeah, I just want to remind folks, do feel free to bring your Python questions in. Paste them into the Slack thread, and I'll be happy to go over them. Yeah, so I suppose without further ado, it's been a pleasure. Looking forward to the next stream. Do feel free to hit me up if you have any questions, outside of stream. Just send me a DM on Slack. I've been pretty busy the past week and this week. Um, so we're just coming up on the interview deadline on the 18th. So things are a little crammed. So if I don't get back right away, you'll know why. Cool. That's it. It's been a pleasure, and have a great rest of your day. Bye bye.